So that's what rational expressions mean. Adding and subtracting fractions with variables, with factors. Factoring is going to be involved. Okay. So I'm going to go through several different things. The approach when denominators are monomials is different than when they aren't. So I'm going to kind of distinguish between the two. Okay. So as we know, when you add and subtract fractions, you must have a common denominator. So the trick to adding and subtracting rational expressions is to ensure that you have the correct common denominator. How you go about finding that is really the trick to this whole section. And so you find a common denominator with monomials, loners, differently than polynomials with two or more terms, the groups. So we're going to do it one way for monomials. We're going to do it a different way for polynomials of two or more terms. And I'm going to separate how we go through these today into those two sort of sections. Bless you. Make sure that denominators are completely factored. Okay, and that's when we're talking about groups. When it's just a monomial, there's nothing to factor. But when I have a group in the denominator, you want them completely factored before you attempt to find the common denominator. Okay, so for monomials, loners. For the coefficient, so keep in mind when you have a monomial, most of the time you have a coefficient, and then you also have a variable part. You're going to find the smallest number that all the denominators go into. So in other words, you find a common denominator like you found a common denominator before there were variables in your life. That's all that a common denominator is. We call it the least common denominator, the smallest number that all the denominators go into. And it could be one of the numbers that's already there. Okay? Because every number goes into itself. So you're looking for the smallest number that all the denominators go into. And then for the variable part, when we factor monomials, we always took the smallest power out with the variable. For variables for least common denominator, we take the highest power on the variable. So greatest common factor versus least common multiple. For least common multiple, least common denominator, you take the highest power on the variable. Okay, so that's for monomials. Okay, once you find the common denominator, you have to multiply each numerator and denominator by whatever is missing from that current denominator to get the common denominator. Now that seems like a bunch of word vomit. And once we start working on problems, it'll make more sense. But the bottom line is you have to change every current denominator into that least common denominator. And in order to change the current denominator into the least common denominator, you're going to have to multiply that current denominator by whatever's missing in order to bring it up to the common denominator. And then, of course, you have to do it to the top two. That's really what it means. And when we start looking at factors, it's going to make more sense, this whole missing part. And then once you have that common denominator, and have completed the top and bottom multiplication, you can add, subtract the numerator. So one of the things that, a common mistake that we make when we add and subtract fractions is we try to mess with the denominator after we've figured out what it is. You just copy that common denominator, and then you add and subtract the tops. And add or subtract the tops. Okay? Copy that denominator once you've found it, and then you add and subtract the tops. And we'll go through several examples here and get some practice at it. These notes kind of give you a recipe to follow. So as you start working, if you're unsure what to do from step to step, you can just kind of follow these notes and go down the list, and it'll help guide you as far as what to do. Alright, let's look at some examples. So here's the first one. Denominators are monomials, okay? There's no factoring that needs to be done. So we can kind of go from there. Go ahead and get that down and I'll talk through what we need to do. Alright, so with monomial denominators, there's no factoring that needs to be done, so I want to break this up into two parts. I want to deal with the 10 and the 15 first. Just like a normal fraction problem. So I need to find the smallest number that both 10 and 15 go into. And my first check is, does 10 go into 15 evenly? And it doesn't. So 15 is not going to be the numerical part of the common denominator. What is the smallest number that both 10 and 15 go into? 30. Okay? Now, so I'm going to just convert both fractions. It's going to be something over 30. Okay? So, on the left fraction, what am I multiplying top and bottom by? 3. And in the right fraction? 2. Okay? Now let's take care of the variable part before we do that multiplication. So I've got an x squared and an x. Your notes told you to take the what? Power. Highest power. So, what's the highest power? X squared. So it's going to be x squared, x squared. Okay? So what do I have to multiply the left fraction by all together? To turn, so here's the part where I'm talking about something's missing. In order to go from 10x squared to 30x squared, what do I have to multiply this by? So what's missing is a factor of 3. And so that's what I multiply top and bottom by. 3 and 3. That's it. Okay? Because in my mind, when I think about what's missing, and it'll make more sense when we do denominators that are polynomials versus monomials. Okay? So what is the top of this fraction going to be now? 9. Okay? Easy enough. Now let's go to the right. What is missing here? What do I have to multiply 15x by to turn it into 30x squared? 2x. Okay? So I'm going to do that. 2x, top and bottom, because the reality is I'm multiplying by 1. So what's the top? 14x. Okay, final answer. Now I can combine, 14x. Now I can combine the top together. 9 plus 14x. I can't do anything with that. They're not like terms. Over 30x squared, and that's all I can do. Okay. Any questions on that? Do one of your own. As you're working through this, kind of keep this idea in mind. The least common denominator is the smallest number that all the denominators will go evenly into. The smallest number that all of the denominators will go into evenly. So, your common denominator should have been 80 a to the third b squared. How many have that? Okay? So notice what I've done already. I'm going to take a little bit of a shortcut, so to speak. That's awful. Let's just write that all over again. 80 a to the third b squared. Okay. I'm going to do my combination of those two in one, sort of skipping a step. So, in this case, top and bottom I'm going to multiply by 5 a to the third, 5a to the third. Okay? So this is 15a to the fifth. So see how I'm combining it all in one step? And then over here I have to multiply by 16b. So this is minus 128bx. So you can do that. So those of you who had that interim step where you had it two separate fractions, ultimately I'm going to subtract the tops anyway. So if you want to skip that little step, you can do it all in one. How many had that? Okay, good. Are there any questions on it before we move on to one with polynomials? If you had it as xb over here and said get in the habit of putting it in alphabetical order, it's not wrong, but get in the habit of putting the letter that comes first in the alphabet first. Okay? Alright, let's look at one more. So here's one that's a little trickier. Because I have groups in denominators. What do you think my first move is going to be? Factor, yep. Factor it out, let's see what you get. Okay, take a look at the screen, see if that's how you factored it out. Hopefully you did. Now, here's where coming up with the common denominator sort of is a departure from what we do with monomials, okay? Keep in mind that these things are all factors. So there's two factors over here, x minus 3 and x plus 2, and two factors over here, 5 and x plus 2. So I have to create a denominator that contains all of that, and not anything more than that. That's what a least common denominator is. It contains all those factors, right? So it's going to have to contain an x minus 3. It's going to have to contain an x plus 2. Does it need to contain two x plus 2s or just one x plus 2? At most, all I need is one, okay? Because each denominator at most only has one x plus 2. And then it also has to contain a 5. So there's three things that my denominator has to have, okay? And I'm going to put them in order this way. So it's going to have a 5. It's going to have an x minus 3, and it's going to have an x plus 2. All of this denominator is contained in here. All of this denominator is contained in here. So I'm in good shape. That's my common denominator. Now, here's where the what's missing kind of applies. So when I look at this denominator, when I look at this denominator here, what is missing from this that the common denominator has? A 5. So really what I'm going to do is I'm going to multiply top and bottom times 5, because that's what's missing from the denominator, right? What about over here? What's missing from this denominator that this denominator has? X minus 3. So that makes sense now what I'm talking about, what's missing? Okay, so now I actually do need to distribute, and keep in mind that this minus goes with the 4. So it's like minus 4. So when I distribute the top on the left, I get 5x minus 5. And on the right, I get minus 4x plus 12. Because of this minus sign being connected to the 4. It's like negative 4. So when I distribute negative 4, I get negative 4x plus 12. So on top now I can combine like terms. So I get x plus 7 over all of my common denominator. And that's my final answer. Now sometimes you're going to be able to cancel. If this was a 2, x plus 2, if this is what it ended up being, I could cancel it with this x plus 2 and make it 1 over that. Okay, so watch for that. Sometimes you will be able to cancel afterwards. Okay? Alright, we're going to spend a couple days working on this. Okay, get some good practice on it. And then we'll have that quiz on Thursday. Are there any questions?